It all starts with reality capture and shared coordinates. This work was all surveyed, and we have the capacity to clean between 150 to 630 million gallons of water a day. A digital twin isn't just a model, it's a live connection between the physical and digital world. You can see everything is scanned with RGB values. We wanted to make sure that whoever was looking at this data felt like they were actually at the plant. And as we continue to build, it's going to improve all of our workflows, enhance collaboration, and really improve all of our data.
Robert Chavez, the Virtual Design Supervisor for the Milwaukee Metropolitan Sewerage District. He works on projects for the district's water reclamation facilities, conveyance network, jurisdictional water courses, as well as green infrastructure. Let's hear it for Robert Chavez and BIM-pacting the future.
Good morning, everyone. Today I'm going to talk to you about building a common data environment. Common data environment provides centralized data management and links all project stakeholders. It's a single source of truth from design to plan to build. You can think of it as a digital hub for models, documents, and data. But first, I'm going to tell you a little bit about Milwaukee Metropolitan Sewerage District. We're a regional government agency that provides water reclamation and flood management services for about 1.1 million people in 28 communities in the greater Milwaukee area. Our mission is to protect public health and the environment through world-class, cost-effective water resource management, leadership, and partnership. We envision a healthier, cleaner, resilient region. We have 2 water reclamation facilities, 6 watersheds within our service area, and 300 miles of regional sewer pipes that carry wastewater to our WRFs. We try to capture rain where it falls, and we do that inside and outside of our boundary, knowing that the water is going to flow towards our treatment plants. And we do this with green infrastructure projects and naturalizing our rivers and streams by ripping out concrete lined channels and just planting native grasses and native trees and ripping out any invasive species. We also have an extensive conveyance network, part of which is our deep tunnel system. It can hold 521 million gallons of water, and it's anywhere from 17 to 35 feet in diameter and anywhere from 120 to 350 feet deep. This is our South Shore Water Reclamation Facility located in Oak Creek, Wisconsin. We have 100 facilities, underground tunnels, and galleries. And this is our first and oldest water reclamation facility, Jones Island, located right outside of downtown Milwaukee, coming up on its 100-year anniversary, where we also have 100 facilities, underground tunnels, and galleries. And between the two, we have 19,000 plus assets, and we have the capacity to clean between 150 to 630 million gallons of water a day. So you can see why a lot of our information would be found in disparate locations and dispersed around among multiple formats, including CAD, Revit, LIDAR, and PDFs. Having everybody working out of files that might have been emailed to them by the design team or the construction team, or maybe our plant operators have a different file, whether it's a hard copy or digital, it's important for us to get everybody in the same environment. With our hard copies, you can find them in libraries at our HQ, at Jones Island, and at South Shore. We also have plans that you can find stuffed behind a conduit or even rolled up underneath a pipe. And my favorite, the red-lined electrical drawing that was just stuffed back into an electrical cabinet, ready for you to discover when you do field verification. And also hanging Mylars. When's the last time you saw that? We also host our data in a number of network drives, in OnBase, which is our document management system for all of our construction and record drawings, and Trimble Unity Construct, which is our construction management software. We also host our master process and instrumentation diagrams, or PNIDs, in SharePoint, which is not a very CAD-friendly environment. And so that's why we decided to implement Autodesk Construction Cloud BIM Collaborate Pro as our common data environment. Autodesk Construction Cloud, or ACC, improves collaboration across multidisciplinary teams and firms, ensuring everybody's working on the most up-to-date and current files, working out of that same cloud, that same common data environment. Now there's no more excuses of, well, which file do you have? I have this one dated this date. Well, this one is actually the most current. It just eliminates those disconnects. One of the primary tools that we use in ACC is Autodesk Docs. Docs eliminates data silos across physical and digital locations. It simplifies tracking and resolution of design issues, and it ensures asset information is accessible in real time, minimizing all those disconnects. It might be one environment, but we have multiple tools, starting with Desktop Connector, which allows us to map our network drives, map ACC as a network drive on our computers, which enables us to utilize Recap Pro to publish LIDAR data straight to ACC. We can also reference our Civil 3D, 2D, and 3D surface files, our Revit 3D model files, and Navisworks Manage, which is our primary BIM viewer. There's quite a bit you can do in BIM Collaborate Pro, including create projects, add members and companies to our main account, and assign them roles, which helps streamline those workflows. We can also develop project templates for each discipline, whether it's watercourse, green infrastructure, conveyance, or plant. And we're also building our standard library, and you can also integrate apps. User management is quite easy with ACC. There are some challenges, like assigning internal and external users to our cloud. We have the ability to borrow a license to a consultant, but the only problem with that is that we're limited on the number of licenses that we have, so I have to be careful with who I give one to. We can add those members to their respective company, and we can assign them their access levels and their roles. I can also add new members, making them an executive or an account admin, depending on what level of access they need. The library gives us the content catalog where we can host all of our Revit families and Civil 3D blocks, cost management for budget and change orders, and even standard forms for daily reports, safety checklists, and correspondence, as well as our standard parameters. The standard parameters can be accessed from both ACC and Revit. Using this function, you can see in both of these images, the same parameters show up in both environments. You can also edit, create, and remove parameters from both of these, using both from Revit and from ACC. And we can create projects easily by both the account and project admin, and we can generate templates. We can create these projects using templates for the respective discipline with the standard folders, structure, and issues and forms, and giving it information such as project type, information, contract number, and anything else. If you wanted to get into the cost management and scheduling, you can start adding start dates and end dates. When you first get into a project, you'll be taken to the project home where you can see information related to the project's location, weather, any outstanding RFIs or issues. The Insight ecosystem allows you to use Power BI to extract data from. You can see scheduling and other information related to that project that you might need access to. You can use Design Collaboration to create work in progress folders for your consulting firms. And then you can also create shared consumable folders for all of those same firms and bring those files into model coordination where we can do clash detection. So we can take the process piping, run clash detection with structural or any other discipline model. And we can also perform our reviews, creating markups right in Navisworks Manage, giving them one file with all the reviews. And document management, where we host all of our 2D and 3D files related to Civil 3D, Revit, and LIDAR. We also host our standard documents for CAD, Revit, and LIDAR, and our templates for Civil 3D and Revit, among other standard documents and data. The project admin module allows you to manage the members, companies, and any information related to the project profile. So one of the first things you do when you create a project as an admin is you activate all the services necessary for that project, whether they need document management, if it's just a Civil 3D project, or if it's a BIM, you're going to want to activate the model coordination and design collaboration and Insight tools. I can also see information about the overall account. How many members do I have in there? Are they from different companies? What type of company are they from? And you can see those red bars. That's the challenging part of the accounts. I have 29 active members, but I only have 16 licenses to give around. So I'm constantly taking away and giving licenses. I can also add new project members, giving them their own default roles with their own default permissions. So if they're a project manager, they might need to see that Insight ecosystem, where if they're a project engineer, they're really just interested in all the files and all the data. Document management gives us the ability to create transmittals, develop review workflows and approval workflows, develop those standard folders for all of our plans and project files, and also create standard issues and giving permissions for who can create and view those issues and close them out. We host all of our files in ACC. So on the left, this is one of our green infrastructure projects, part of our Green Highway initiative, where we're trying to capture water, and we're redeveloping the areas underneath the highway so that we can capture all that water with native grasses and plants. And you could see that this work was all surveyed via CSVs. We imported that, created the surfaces, which you can see they're gray, but they are annotated, along with the curb and gutter, sidewalk, and other features that were captured. On the right is our equalization and blend facility, so you can view that in ACC as well. And you can jump into saved perspectives and those views. And in both drawings, you can create markups and leave comments behind and publish those or keep them private, whatever you desire. If they're for me or one of my staff members to update the file with, then you can publish that for us to see, and we can make those edits. We also host our master P&IDs, or process and instrumentation diagrams, in ACC. This gives us the ability, and our SPMs, our senior project managers in the field, to update and mark up these P&IDs with real-time changes. One of the biggest challenges with these is that our plant operator, Veolia, North America Water, they will make changes, and sometimes we don't know about them right away just because they weren't part of a larger contract. And so we don't see these changes, and that's the red-lined electrical drawing that you find in the panel. So if one of our SPMs is out there, they can mark these up, publish them, notify us, and we can update them in real time before they're even back in the office. And then we can create new PDFs, upload them to both ACC and SharePoint, where we have no license issues, and so more people can view them and use them. We can also develop permission, and permissions in ACC are inherited from the parent folder. So whoever's added to this project with their default roles, I can set up their folder permissions if they're a viewer, a creator, or a doer, or an editor. Permissions can also be reset. So if I added more people and I decided, well, you don't really need permissions to download or view, or download or edit, I can make you just a viewer. If you do need full control of the folder, which some of my staff do, so they can add other senior project managers or other staff, I can give them those permissions. So it's all hierarchy and it's all inherited, but you can update subfolders to reflect permissions that are necessary for those folks. You can also go back in your version history for all of your files, whether they're CAD or Revit. This is a Revit model that we have 468 different versions of. What we can do is go back and compare those. We can also make those older versions current if we feel like we need to go back to that stage of design. In this case, we are overlapping the data, the model, and you can see it's color-coded based on what's been added, what's been modified, and what's been removed. And like I said, if you found that you needed to go back, you can always make one of those current. You can also visualize those 3D surfaces that I was just talking about on our green infrastructure projects. On the left is our Jackson Park Watercourse project, where we are redeveloping this area. We're ripping out concrete lined channels, naturalizing the creek, and we're improving the park for both the public use, but also for flood management. So this is just the 3D surface, and you can see all the line work that is also elevated is coming along with that surface, and the SPM on the project or a consultant that has access to this project can also mark it up. These changes do not get reflected in the CAD file themselves. They're only viewable in ACC. And on the right is another one of our green infrastructure, green highway projects for the Port of Milwaukee, where you can see that's a 3D surface. Those gaps are actually where the highway ramps are, and so we didn't survey those. They weren't a big part of this project, even though it is green highways. You can also create and track issues in ACC. So this is a project that I worked with one of my surveyors on. This is Wilson Park Creek, another watercourse project. And what I noticed in the surface was an area that looked a little wonky, so I created this issue, and I asked my surveyor to go out there and verify. And right from his tablet, he was able to take pictures and upload them straight to the ticket, closing it out, telling me that everything looked fine and that the surface was good to go. You can also generate reports of these issues. One of the more powerful aspects of these reports is all the ID numbers are hyperlinked back to the drawing that the issue was created in. So as long as the person looking at this report has permissions and access to those files, they can hop back into that drawing and see why and when that issue was created, and even investigate other issues that are part of that same project. How do we go from reality to digital? It all starts with reality capture and shared coordinates. Shared coordinates is something that we hold close. That's one of the standards for all of our CAD, Revit, and GIS data. And so when we're scanning with our Faro or our DJI drone, we want to make sure everything is matched up properly. And that gets us to our scan to BIM process utilizing Recap Pro, Civil 3D, Revit, and Edgewise. Those softwares allows us to create as-built BIM models that improve our asset management, operations, and maintenance, and quickly become the single source of truth for that facility. And where we want to go is towards the digital twin, taking those models and linking the sensor data, making them more dynamic, giving them the ability to simulate and predict based on information that's flowing through them, as well as any design criteria for upcoming projects. This is our terrestrial laser scanner, the FaroFocus S150. That's not one of our surveyors, but some of the challenges that we did face are end-to-end elevation mismatches in our tunnels, line of sight limitations, and reflection issues with stainless steel piping. We were able to improve some of those areas with refined scanning approaches by using tighter scan positions, raising and lowering the scanner in certain positions where pipes were next to each other, on top of each other, making them harder to see, even inverting the scanner to capture the top of an asset or structure, and then changing quality settings, which can add time but does improve clarity. This is an example of the LIDAR data that was scanned for our equalization and blend facility at Jones Island. You can see everything is scanned with the RGB values. Our process piping are painted certain colors, so we wanted to make sure that whoever was looking at this data felt like they were actually at the plant. And as you can see, just how tight and how complex some of these areas can be. And we have 100 more facilities like this in galleries and tunnels that we need to capture. This is our drone, the DJI Matrice 350 RTK. It's equipped with a DJI P1 for photogrammetry, a DJI L2 for LIDAR, and a soon-to-becoming thermal camera. We've only had it for a couple months, but we've already faced a couple challenges with it, one of them being shared coordinates. We use it on a project that was started probably 7 years ago now, and we used an old datum, standard datum, and this data is being collected on the new datum, so we're going to have to align it with the old data. Also, black and white targets are hard to see in scans, and motion blur and voids from cars driving by. The drone has helped us improve by giving us increased speed and coverage, scanning 110 acres in an hour and 15 minutes, and also safety, where projects might have steep slopes or water hazards. And in case you don't believe me, that is our scanner in action with our pilot Jacob, who is in the audience today. This is an example of that drone photogrammetry taken with the DJI P1 on that same project, Western Milwaukee. These screenshots were taken from Pix4D Matic. You can see just that level of detail on how much better this is than any survey base layer that you might be using for your aerial backgrounds. And this is the levee monitoring scan data taken with the DJI L2. These screenshots were taken from DJI Terra, and what he was able to do was classify the points from ground and above ground and extract all the trees and the buildings, giving us a really well-defined levee and contour system as it flows down to the Menominee River. We also bring these points and transform them into assets. We publish our data using Recap Pro 25 into ACC, where we can view it, and we can also use feature extractions and dimension tools. In the middle, you can see I'm using a break line generator, giving it the desired interval, and I can also move those nodes around wherever I want my point to be, and I can tell it to automatically or manually extract line work. I can also extract individual points for manholes, light poles, power poles, or any other feature that you might want, and that can all be exported into Civil 3D, or you can even export it as a CSV. We're also using the LIDAR data to model our facilities. This is our equalization and blend facility with the point cloud data overlaid. We also modeled this building using our record and construction drawings, but as I just showed you, the age of our documents and the accuracy of them is sometimes questionable, and so we wanted to scan everything before going through this process of modeling. We also use that LIDAR data to create custom families, custom Revit families for all of our BIM models, and then we assign our standard parameters, whether they're text or URL. The text parameters come directly from our asset management database, and then our URLs are all databases that we want to integrate into our BIM models. We also use automated tools like Edgewise to extract process piping. So this is the point cloud data that I imported into Edgewise, and it automatically extracted based on my tolerances and some cleanup. I'm not going to lie to you, but it was very, very easy to use, and I was able to export these pipes to a Revit format that we could import and create our as-built BIM models. This is our South Shore effluent pump station, which was our first BIM model created during our pilot program. I believe this one was created back in 2019. This is our return activated sludge pump station and return activated sludge waste activated sludge gallery at Jones Island. This was our second BIM model and our first in-house BIM model that we created and completed. This is our equalization and blend facility at Jones Island and solids gallery and RAS-WAS gallery, which links up with the previous model that I just showed you. So now we're building a continued network of our galleries and tunnels, matching everything up. We also use our models in Navisworks Manage for model coordination, where you could take dimensions, cut cross-sections for presentations like this or whatever you might need them for. And you can even bring people into saved views and perspectives that they might not normally be able to get to. Like inside of this tank, there is a hatch to get in there, but I don't have a key for it, and I don't think they would give me one anyway. But we also link asset information to this model too. Over the past couple of years, MMSD has been on a bit of an excursion trying to do digital transformation or digital evolution. And right now, we're trying to get from that 2D static environment to a more digital dynamic environment, both with our models and with our processes and pipes and even the documents that we use, trying to use less paper. Right now, I would say we're in the convergence stage where we do have those 3 BIM models that I showed you, both in Navisworks, but we also use Esri ArcGIS Portal as our primary web viewer. Part of the process for creating these BIM models is asset discovery. So one of the problems that we ran into on this job, we found 25 assets that did not have a matching equipment ID or asset ID, and they were not tagged in the field or somewhere in the database. So we had to work with both asset management staff and our plant operators to physically go out there and locate these, referencing our construction and record drawings and trying to just figure out which valve was which or which pump was which. And that led to a more complete model as well as an updated and improved database for all of our asset management. And again, with this model, you can just see how complex these areas can be. Here we go. That's the first floor of the equalization and blend facility. We modeled this with a high level of development, which is level of detail plus level of information. You can see a lot of the structural and architectural components are a lower level of detail, LOD 100, where a lot of the assets that we care a lot more about and want to track more are LOD 350 to 500, just depending on what they are. And as I get closer to my desired asset in Navisworks Manage, I can click on the links button, which is found on the ribbon, and that'll pop up a bunch of little yellow hyperlinks that might be kind of hard to see on these screens. But what I can open up is Bicycle, which is our asset management software, which shows me all the information related to this asset. When was it installed? Who installed it? Were there any contracts that modified it, and by who? I can also see information based on work history, inspections, and asset life assessment. I can also open up our standard process and instrumentation diagrams from SharePoint. And this is all for people that have access to our network. And I can also open up OnBase, which is our document management system, which hosts all of our record and construction drawings. All of these drawings are linked back to these assets by asset ID. So you can see this drawing had about 25 different asset IDs linked to it. And we're trying to clean that up. We found some errors in that. I can also open up Autodesk Construction Cloud, which will take me to the project that developed these models, so I can get into any of those individual discipline files. I can also open up Trimble Unity Construct, formerly eBuilder, which is our contract management software. And I can also open up ArcGIS GIS portal for our web viewer. This video was created when we only had one of our Jones Island models in here, but we do have 3D shells of all the other facilities. Once I zoom in, you'll be able to see it. And down there is our RAS-WAS building pump station. And once I got in there, you could see all the same links. And I can also open up any O&M manuals related to this facility. A digital twin isn't just a model, it's a live connection between the physical and digital world. On the physical side, we have systems, assets, and spaces. On the digital side, we track streams of data, behaviors, and events. And together they create a smart, dynamic model which helps us make better decisions and improve operations. So taking our models and putting all the assets together with them, putting them into tandem, linking all that information together will give us those dashboards for humidity, energy consumption, temperature, which is important in some of our facilities, or even dust collection for our dewatering and drying facility where we make Milorganite, which is our fertilizer. So this is where we want to go, creating this web-based Autodesk Tandem digital twin models that everyone can have access to. And as we continue to build and implement Autodesk Construction Cloud as our common data environment, it's going to improve all of our workflows, enhance collaboration, and really improve all of our data, giving everyone access to those same files, those same DWGs, Revit, and LIDAR. Thank you for your time.